Cumulative frequency curves. A cumulative frequency curve is a graph that plots the accumulated frequencies less than or equal to the endpoint of an interval against the value of that endpoint. In other words, it illustrates how quickly a phenomenon accumulates in value as we measure it. So this is best illustrated by means of an example. Example C. The following grouped frequency table shows the number of new signups for a social media platform since it was started a year ago up until today. The first 60 days had 1,500 new signups. The next 60 days had 4,250. The following 60 days, 15,000, and so on. The cumulative frequencies are calculated as follows. So from the data above, we can see that there were 1,500 new signups, which occurred in the first 60 days. Over the next 60 days, there were 4,250 new signups. So cumulatively, this meant that there were the first 1,500 plus the next 4,250. In other words, a total of 5,750 signups in the first 120 days. In the third 60-day period, there were an additional 15,000 signups. So cumulatively, this would mean that there were 1,500 for the first 60 days, 4,250 for the next 60 days, plus 15,000 for the next 60 days. So in other words, 20,750 signups in the first 180 days. So we continue in this fashion until we have counted all of the observations over the entire 360-day period, and this is shown in the table below. We would then proceed to plot the cumulative frequency on the y-axis against the right-hand endpoint of each interval on the x-axis. From the table above, we would then need to plot the following coordinates: 60 for the first 60 days on the x-axis, and the cumulative frequency of 1,500. Then 120 for the next 60 days on the x-axis, and then 5,750 for the cumulative frequency on the y-axis. On the x-axis, the next point would be 180 days, and then the cumulative frequency on the y-axis would be 20,750. And we'd continue in this fashion until the last interval, which is 360 days, which would have a cumulative frequency on the y-axis of 75,800. So from the initial data we were provided with, we would not be able to determine the exact number of signups each day. The only thing that we would know is the date range in which certain signups took place. So for example, we know that the first 1,500 signups occurred in the first 60 days, and that the next 4,250 occurred in the next 60 days. However, we are unable to determine the exact number of new signups on, say, day 61, 62, or 63, for example. So a cumulative frequency curve can be used to estimate such quantities. We'll do two examples. Estimate the number of members on the social media site on day 200. And example 2. Find the day on which the site signed up approximately 66% of its current membership. Solution 1. Let's try to estimate the number of site members on day 200. We first need to find the 200th day on the x-axis of our graph, and then read off the corresponding value on the y-axis, the cumulative frequency. Reading from the graph, the 200th day had a cumulative frequency of about 29,000 users. Part 2. Here, we need to find the number of members representing 66% of the total membership of the site. If the total number of members at the end of the period amounted to 75,800, then 66% of this represents 50,028 members. We would then need to find the value of 50,028 on the y-axis, and then find the corresponding x-axis value. This would represent the day when the site reached 66% of its membership. This is shown in the graph below. We can estimate from the graph that the site acquired 66% of its membership on day 255. We should always bear in mind that the data read off a cumulative frequency curve is always an estimate, since the line which joins up the dots is just an approximation of the growth in frequency of the variable being studied. We were not given the exact dates of all the members signing up to the site, and therefore we had to estimate this data from what we were given.